Hello students. Here we'll study continuous probability distribution function. So earlier we have studied discrete. So what is the main difference? Suppose this probability distribution function is defined continuous probability between 0 to 1. So take an example, a point between 0 to 1, that is zero point 0.7. So fx will be f zero point 0.7 will be 3 into 0.7 the whole square, that is greater than 1. So this is not possible because we know that sum of all the values between this one should be equal to 1. So if you take an interval minus infinity to infinity 3x square dx. So here it is defined between 0 to 1. So we can distribute it in three parts: 0, 3x square dx plus 0 to 1, 3x square dx plus 1 to infinity 3x square dx. So this is 0 and this is 3x square by 3, 0 to 1, and that is equal to 0. So this is equal to 1. So what is the cumulative distribution function? So cumulative distribution function is, suppose this equation is this equation, we can draw a graph like this, and this is 0 and this is 1. So what is PDF? PDF is this line, this graph is PDF. So here you can minus infinity, here also you can draw up to the minus infinity. So this graph, this, this, uh, this, this, this is PDF, PX, probability distribution function. And the area, suppose one variable is x, 0 to x. So that is called cumulative distribution function, CDF. CDF is nothing but then Px. You take minus infinity to x dx. So you divide into two part, minus 0 to 0 Px dx, plus 0 to x Px dx, and plus that you need not do. So this will be how much? 3x cube divided by 3 and 0 to x. That means equal to x cube. So this is the CDF. So now you understood the PDF. PDF will be always defined between the interval, and CDF will be any variable point x and that interval, area between that interval. So if you x is increased, that it will increase, and maximum CDF will be 1. So similar to discrete, it is also defined between certain value of x. Suppose a to x. Suppose between interval a to b dx. So this is for CDF, cumulative distribution function. So let's see the formula and remember the formula. So P if x belongs to certain interval, suppose a, or you can let's say minus infinity to infinity, then minus infinity to infinity px dx must be 1, and cdf is equal to cdf, suppose cdf is defined between ax b, then a to b ft dt is equal to fx. This is cumulative distribution. Now we'll solve some questions. Let x be the continuous random variable probability density fx is equal to x cube. That means if px or fx, whatever you want, take. And for an interval 0 to c. So for interval 0 to c, that means x cube by 4 px 0 to c should be equal to 1. That is x4 by 16, 0 to 1, 0 to c. That means c to the power 4 by 16 is equal to 1. Should be 1. So c4 is equal to 16 and c is equal to 2. So answer is 2. Now come to the next question. Three. Let us return to the example in which x has the following probability distribution function 0 to a. What is the cumulative distribution function? So fx is equal to fx 0 to 1 is the cumulative distribution function. So 0 to x. That means x should be between 0 to 1. So 0 to x dx. So 0 to x 3x square dx. That means x cube. So this is the cumulative distribution function x cube. Now come to the question number 4. 4. That is x cube by 4. X cube by 4. So what is the little research here? That the probability distribution is 0 to 4. What is the cumulative distribution function? So fx is equal to again start from 0, 0 to x cube by 4. So x4 by 4. So x4 by 16. So x4 by 16 is the answer. Now come to the next question. Suppose PDF of continuous random variable x is defined fx is equal to 4 minus 1 to 0, and this is 0 to 1. So what will be the fx? So fx will be x plus 1 minus fx. Fx. So actually this is not a differential equation. The curve will be like this 0, 1, and here this is fx is equal to x plus 1, and this is fx is equal to 1 minus x. It will start from minus 1 to 0, and this is 1. So suppose we want to do the cumulative distribution function. So this will be add. So for so we can define fx for x less than 0 to minus 1. So that will be equal to fx means x plus 1 and 0 to x. So that is x square by 2 plus x. So that will be the answer. And for here this side suppose x is 0 to 1. So here this area is half. This area is half. So half plus fx from where to where? From 0 to x. So plus dx. So half plus 0 to x. Fx is 1 minus x dx. So half plus plus x minus x square by 2. This is the probability distribution function. So piecewise also probability cumulative probability distribution function can be CDF can be defined. PDF here also piecewise. So CDF also piecewise can be defined. Now come to the question number. Verify a function PDF or PDF of a continuous random variable x, where x is fx e to the power minus x for 0 to infinity. So e to the power minus x 0 to infinity dx. So that is e to the power minus x minus 0 to infinity. So e to the power minus infinity is 0 minus 0 minus e to the power 0 is 1. So that is 1. So this is defined. That is not an issue. Second, this is x square. This is x square. No? Second. Second is x is equal to x by 2. X square. X by and minus 2 to 2. So for the function to be defined, fx dx minus 2 to minus 2 to 2 and remaining other and 0. 0 for others, other intervals. So minus 2 to 2. So minus 2 to x by 2 dx. That means x square by 4 to minus 2. So 4 by 4 equal to 1. and this is also 1. 1 minus 1 is 0. So this is not defined. So second is not defined. Second is not defined. Now come to the question number 7. Find k is the following function PDF of random variable x, that is fx is equal to and 0 to 1. So PDF is fx k x square 1 minus x. That means fx minus infinity to infinity dx will be equal to 1. But it is defined between 0 to 1 and remaining is 0. That means minus infinity to 0 fx dx plus 0 to 1 fx dx plus 1 to infinity fx dx. This will be 0. This will be 0. So only this we have to find out. So that is x square minus x cube dx 0 to 1. So x cube by 3 minus x4 by 4 0 to 1. And 1 by 3 minus 1 by 4 is equal to 1. So k 1 by 12 is equal to 1. So therefore k is equal to 12. Now come to the question number 8. For each of the following PDF of random variable x, find x is p, x is less than 1, b, p, if fx is equal to define minus 3 to plus 3 and 0 otherwise. So first is PDF fx is equal to x square by 18, and it is defined between minus 3 to 3, otherwise 0. So first we have to see whether this is minus 3 to 3, this is 1 or not. So x dx minus 3 to 3, remaining 0, remaining will be 0. So that is x square by 18 minus 3 to 3 x cube by 27 3 minus, so that is 27 by 7. 2797. So that is coming. So this is x cube by 3. That means 54. So this will be 1 by 54. 27 minus of 27. So that is equal to 1. So it's a random variable. Now we have to find P1. So fx dx minus 3 to 1 is equal to that is equal to x cube by 54 minus 3 to 1 54. So that is equal to 1 by 54 1 minus of minus 27, that is 28 by 54, that is equal to 14 by 27. Now come to the second question, that is mod of x is less than 1. That means x should be greater than minus 1 and less than 1. So minus 1 to 1 x square x cube by 18 dx equal to 1 by 54 x cube 1 to minus 1, that means 2. So that is equal to 2 by 54 is equal to 1 by 27. So that is the answer. Now come to the second question. Second question, random variable is x plus 2 by 18. X plus 2 by 18. So first minus 2 to 4, you see dx minus 2 to 4. So 1 by 18 x square by 2 2x minus 2 to 4. 1 by 18 1 by 4. So that is 8 x cube x square by 2 x square by 2 6 square by 2 so here it will be plus x square minus 4 minus 2 minus 2 minus 4 by 2 and minus plus, or it can write in such a way. This one is minus and this is minus 4. So that is 1 by 18 into 18. So that will get cancelled 1. So now you can find in the interval. So how you can find in the interval? What is the interval? Interval p is less than 1. So p is less than 1, that means minus 1 to 1 x plus 2 by 18 dx. Then 1 by 18 x square by 2 plus 2x 1 to minus 1. 1 by 18 1 by 2 plus 2 minus 1 square by 2 minus 2. So you calculate it, you will get 1 by 4 minus of minus 1. So minus 1 is plus 2. So you will get 4, 1 by 4. Similarly, you can find that also. Now come to the last question. Last question 3 2x square. So first you find out that whether it's a random variable or not. So for random variable fx dx is equal to 3 1 minus 2x squared defined 0 to 1 0 to 1. So that is equal to 3 x minus 2x cubed by 3 0 to 1. So that is equal to 3 1 minus 2 by 3. So that is equal to 1. So it's a random variable. Then CDF, you have to find CDF. So CDF, it starts from 0. So you take any variable x, 3 minus 1 minus 2x square dx. So 3x minus 2x cubed by 3 0 to x. That is equal to 3x minus 2x cubed by 3. That is equal to 3 get cancelled, and here 3x minus 2x cubed. So this is CDF, cumulative density function. So graphically we understand the just suppose fx is defined here. So this area x. Suppose is start from infinity, and from here to here it is 0, and here 1, and here this one. So 1, here x. So here it was 0. So here 0 x. So this area is cumulative density function, and this line is PDF, probability density function. So suppose it is fx, this function, this line is fx, then in this area will be fx into dx 0 to x. This is CDF, and fx is PDF. Thank you.